Imagine staring into the deep black of space, where silence reigns and nothing stirs for billions of miles. Then, suddenly, something glitters. Not the usual sparkle of a star, not the faint shimmer of a distant galaxy. This is closer, brighter, stranger, a trail of metal. Yes, you heard me right. Metal, an object streaking through our solar system, is bleeding 10 pounds of nickel every single second. Stop and think about that for a moment. 10 pounds a second, that's 600 pounds a minute. Over 17 tons of nickel every hour. Imagine dumping an entire dump truck full of polished coins out into space every single day. That's what this thing is doing, casually, relentlessly, as it races past our planets. And it makes no sense. Because in the grand factory of the cosmos, nickel never comes alone. It's born with a twin ion, forged together in the death throes of stars, locked hand in hand inside meteorites, fused at the core of planets. Out there, in the natural universe, you don't get one without the other. But this object, it's breaking the rules. The nickel is there in abundance, but iron is nearly absent, almost zero. Now here's the problem. On Earth, the only way you see nickel separated from iron is if we do it in factories, in smelters, with industrial processes that take immense energy and precision. In other words, technology. So why is this so-called comet trailing pure nickel into the void like a busted machine? That's the riddle that sent shockwaves through astronomy. And one Harvard scientist didn't hesitate to say what everyone else was afraid to whisper. This might not be a comet, he warned. This might be technology. Because if he's even half right, then what we're watching is not a random piece of rock or ice. It's deliberate, a signal, a breadcrumb in the dark, a trail left by someone or something far older than us. And here's the kicker. The metal isn't the only thing that's wrong. When telescopes zoomed in on the faint haze around this object, the coma, that glowing cloud of gas and dust that comets usually throw off, they expected the usual suspects. Water vapor, frozen dust, maybe a splash of carbon monoxide. Instead, they found carbon dioxide. Not just a little, but a staggering amount. 8 parts carbon dioxide for every 1 part water. Do you understand how bizarre that is? Here in our solar system, comets are like dirty snowballs, mostly frozen water, sprinkled with a few other gases. The typical ratio is something like 4% carbon dioxide to water. But this thing, it's flipped on its head, 8-to-1. This isn't how comets are made. Not here, not anywhere nearby. This is alien chemistry. So now we've got a visitor that isn't just moving fast. It isn't just spitting impossible metals. It's literally made of the wrong stuff. And that brings us to the next mystery, the way it moves. Picture the solar system like a giant record spinning in space. All the planets, Mercury, Venus, Earth, Mars, the gas giants, their grooves in the vinyl, circling the sun in the same direction, more or less on the same flat plane. When something from deep space drops in, it usually cuts across that record like a needle scratch, a smooth curve, in and out, gravity doing the work. But not this one. Atlas, as astronomers are calling it, isn't drifting, it's threading. Its path swings dangerously close to Venus, brushes past Mars, then slides toward Jupiter, all in one visit. And the odds of that happening by random chance? 0.005%. To put that in perspective, you're more likely to be struck by lightning 3 separate times in your life than for an interstellar object to just happen to fly this route. So is it luck, coincidence, or something else? Here's the eerie part. Atlas isn't even moving with the traffic, it's going the other way. A retrograde orbit. If you wanted to design a survey probe, something to sweep past all the inner planets and grab a good look, you'd put it on exactly this kind of path, driving the wrong way down the one-way street of the solar system. Every planet, every vantage point, neatly lined up for inspection. That doesn't feel random anymore. That feels intentional. And as if the metals, the chemistry, and the trajectory weren't weird enough, the universe decided to twist the knife. When this object makes its closest pass to the sun, it's perihelion, The point where it would flare brightest, where we could see its full glory, it just so happens to do it on the far side of the sun. From Earth's perspective, it's hidden. At the exact moment we need to see it most, it vanishes behind the glare. Coincidence? Maybe. But stack it with everything else. The nickel, the missing iron, the alien chemistry, the deliberate path, and coincidence starts looking thin. Now let's zoom out for a moment. Imagine you're designing a machine, a probe, something to travel across the stars. You don't want it to be obvious. You don't want it to scream, "Look at me, I'm alien tech." Instead, you make it look like a comet, a dirty snowball, harmless, forgettable. But you lace it with signals, breadcrumbs, things that a curious civilization with good enough telescopes might spot. Pure nickel, wrong chemistry, a trajectory that defies probability. It's like a puzzle, a message hidden in plain sight. And the message says, if you're smart enough to notice this, you're smart enough for us to talk to. That's one interpretation. The other, something darker. What if it isn't a message at all? What if it's a test, like a lure dropped into a pond waiting to see if the fish bite? Because let's face it, the very fact that you're watching this video proves the bait worked. Humanity saw it, we noticed, and now the only question left is, what happens next? Think about the layers here. Draw a cosmic visitor bleeding industrial-grade nickel, missing iron that screams refined, a chemical cocktail no comet in our backyard could ever have, a trajectory that reads like a survey mission, retrograde motion as if it's maximizing coverage, and a perihelion that neatly ducks out of our sightline. On their own, each one could maybe be explained away, but together they paint a picture that feels deliberate. It looks less like a comet and more like a probe. A probe from who or what we don't know. But the fact that it's here at all means one of two things. Either nature is far weirder than we ever imagined, or we are not alone. And right now, neither answer is comforting. So here we stand, on the edge of discovery or revelation. An object from the stars, breaking all the rules we thought were unbreakable. A machine disguised as a comet, or a comet that laughs at our definitions. Maybe it's garbage, a piece of some ancient alien factory drifting aimlessly. Maybe it's deliberate, a survey, a probe, a message in a bottle cast across the galaxy. Or maybe it's a test, a lure. And if it is, then the test has already been passed. Because we saw it, we recognized it, we're talking about it right now. And that means whoever left it out there, they know we're watching. So buckle up, because this is only the beginning of the mystery of 3i Atlas. The universe is messy, chaotic, explosive. Stars live, stars die, and in their death throes they forge elements in violent abundance. Iron, nickel, oxygen, carbon, all hurled into the void in tangled bundles. Nature doesn't like neatness. It doesn't separate. It doesn't refine. That's why Atlas is so deeply unsettling, because what it's doing isn't messy. It's precise. It's surgical. It's industrial. Let's talk about nickel. On Earth, nickel isn't glamorous. It's not gold. It's not platinum. You don't wear it on a ring or lock it in a vault. But nickel is everywhere in our technology. It's in stainless steel, in turbine blades, in the rechargeable battery in your phone. It makes metals stronger, more resistant to corrosion. It's the quiet backbone of industry. In fact, our entire transition to electric vehicles hinges on nickel. High-performance batteries, like those in Teslas or in satellites, use nickel because it stores energy more efficiently. The higher the nickel content, the more power you can pack into a small space. Nickel is also used in spacecraft alloys. If you want a machine to survive the extremes of space, radiation, cold, heat, micrometeorite impacts, you want nickel. It keeps metal from cracking. It keeps systems alive. So when Atlas started shedding pure nickel into the void, some scientists didn't just see chemistry, they saw a signature, a technological fingerprint. Now, let's be clear. Nickel exists naturally in space. It's forged in supernovae like iron, but always together, always messy, always locked together in the raw ore of asteroids and planetary cores. To separate nickel from iron, you need industry. On Earth, that means smelting, mining, energy, fire. We dig ore out of the ground, we crush it, we heat it in blast furnaces that roar at thousands of degrees. We pump in chemicals, we burn fuel, all of it to pry nickel away from iron, to extract one clean element from the mess. It's not easy, it's not natural, it's technological, and Atlas is doing it in space, effortlessly, silently, constantly. 10 pounds a second, 17 tons an hour, hundreds of tons a day. A comet that bleeds industrial-grade nickel as if it were nothing. That's why Avi Loeb called it out. That's why Harvard's voice matters here. Because in science, reputation is everything. You don't just stand up at a podium and say, "Hey, I think we found alien technology," unless you're ready to have your career set on fire. Loeb did it anyway. And here's what makes his warning powerful. He's done this before, back in 2017, when Oumuamua zipped through the solar system like a cigar-shaped ghost. It accelerated mysteriously as it left the sun. No tail, no visible jets, just speeding up. Loeb looked at that data and said, "This could be a solar sail, a piece of alien technology." The world scoffed, scientists laughed, he was ridiculed in the press. But he didn't back down, he doubled down. He wrote a book, he defended his analysis, and even as critics piled on, he forced the world to confront the possibility. And now, with Atlas, he's back. The same man, the same reputation, the same courage to say what others are afraid to. This isn't just a comet, he insists. This could be technology. And when Harvard backs a voice like that, people listen. But let's not stop at the surface. Let's ask the real question. If this is technology, what kind is it? Because nickel isn't just a material, it's a resource. Is Atlas spewing waste? Is it leaking like a broken machine? Nickel spilling into the void as useless byproduct? Or is it broadcasting? Using nickel as a signal, a beacon, a flare that says, "Look closer, we're here." Or here's a darker thought. What if the nickel isn't waste at all? What if it's the payload? Think about it. You're an advanced civilization. You want to seed the galaxy with probes, factories, or self-replicating machines. You need resources, strong metals, alloys that can survive. So what do you send out? You don't send a fragile one-off probe. You send a machine built to carry its own factory floor. You send it with nickel. Nickel to build, nickel to replicate, nickel to survive. What if Atlas isn't bleeding out its secret by accident? What if it's demonstrating capability, like a magician pulling a coin from thin air, showing you what's possible before revealing the real trick? And here's another angle, efficiency. If Atlas is a probe, maybe it doesn't need to carry much equipment. Maybe it just needs a seed, a starter kit, a few elements that can unlock the rest. Nickel could be that starter kit. Combine it with what it finds, hydrogen, oxygen, carbon, and suddenly you've got alloys, energy systems, even the building blocks of new probes. That's the logic behind what we call a von Neumann probe, a self-replicating machine that mines resources, builds copies of itself, and spreads like spores across the galaxy. If that's what Atlas is, then what we're seeing might not be waste. It might be reproduction. Now I know what you're thinking. Isn't this all a little too wild? Couldn't there be a natural explanation? Sure, scientists are working overtime to find one. Some suggest rare types of supernovae might blast out nickel without iron. Others say maybe it's the debris of exotic collisions, like neutron stars smashing together. But here's the problem. Even if those extreme events created something like Atlas, the odds of that debris being flung on a path that threads through Venus, Mars, and Jupiter while traveling retrograde, while hiding its closest path behind the Sun, are astronomically small. It's like lightning striking the same person on the same day in the same place 3 times in a row. Possible? Yes. Probable? No. At some point, improbability starts to look like intention. And this is the heart of Harvard's alarm. Because if Atlas is natural, then fine. It rewrites textbooks, forces us to rethink stellar chemistry, and expands our view of cosmic possibility. That's exciting enough, but if it's not natural, if it's industrial, if it's technology, then we're not just rewriting textbooks, we're rewriting history. It means we are not alone. It means the galaxy is not silent. It means someone else has been here before us, maybe still is, and they left their fingerprints in the trail of nickel flowing through our solar system. And that's what terrifies some scientists, because acknowledging that possibility means acknowledging vulnerability. It means admitting that humanity, with all our telescopes and rockets and satellites, might just be ants in a universe run by giants. And yet, ignoring it doesn't make it go away. The nickel is there, the iron is missing, the physics doesn't add up. So the scientific community stands divided. Some cling to natural explanations, however improbable. Others, like Loeb, look at the data and say, there's a story here, and it doesn't look natural. And all of us watching from Earth are left with the same question. If this really is technology, if Harvard's alarm is right, then who built it? Maybe it's a probe from an ancient civilization, drifting for millions of years before finally crossing paths with us. Maybe it's a delivery system, carrying nickel and gases as part of some grander mission. Maybe it's just garbage, space junk from a machine far older and far greater than anything we can imagine. But whatever it is, it's industrial. It's precise. It's not the universe being messy. And that's the part no one can explain away. So as Atlas streaks across our skies, shedding its impossible metals, one thing is certain. This isn't just another comet. It's a puzzle, a provocation, a piece of evidence that dares us to look beyond our comfort zone. And thanks to Harvard's alarm, thanks to the nickel trail, thanks to the courage of one scientist willing to speak the unthinkable, we're forced to confront the possibility that changes everything. The possibility that somewhere, out there, in the vast and silent theater of space, we are not the only players on the stage. Imagine baking bread. Every recipe calls for flour, water, yeast. Sure, you can play with the details, add sugar, salt, maybe some seeds, but the foundation is always the same. Now imagine pulling a loaf out of the oven and realizing it's made of cement. It looks like bread, it smells like bread, but bite into it and your teeth break. That's the level of shock astronomers felt when they looked closely at 3I Atlas's chemistry. Because on the surface, it looks like a comet. It has a coma, a faint tail, a dusty halo. The stuff we've seen before. But when they cracked open the recipe, the ratios of gases inside, it wasn't bread anymore. It wasn't even close. It was something alien. Let's start with the biggest shocker, carbon dioxide. On Earth, we think of CO2 as the invisible gas warming our planet, filling soda cans, puffing out of car exhausts. In space, it's not unusual to see a little CO2 in comets. They form alongside water, frozen together into the dirty snowballs that drift at the edges of solar systems. The ratio is usually small, 4%, maybe 5%. That's the recipe we know. But Atlas? It flipped the recipe upside down. 8 parts carbon dioxide for every 1 part water, 8-to-1. Let that sink in. If you're used to Coke being fizzy and bread being soft, this is like cracking open a soda and finding it's all gas, no liquid. Like biting bread and tasting concrete. This isn't just unusual, it's impossible by our standards. Because water is abundant in our solar system. It's everywhere, locked in ice caps, frozen in asteroids, drifting in comets. CO2 exists, yes, but not in this kind of overwhelming dominance. So the obvious question is, why? Scientists scrambled to explain it. Maybe Atlas formed in a star system radically different from ours, where carbon dioxide was the king ingredient and water was scarce. If so, then it's a window into alien geology, alien planetary chemistry. But here's where it gets weirder. CO2 isn't just a random gas. It's a builder. On Earth, carbon dioxide feeds plants, fuels photosynthesis, drives cycles that keep ecosystems alive. For technology, it's a signal. If you're designing terraforming machines, factories meant to seed worlds with life, CO2 is a great ingredient to pack. It's the stuff you'd spread into an atmosphere to spark growth. So what if Atlas's bizarre chemistry isn't an accident? What if it's deliberate? What if this object isn't just carrying a strange mix of gases, but a payload? And CO2 is only the beginning. When astronomers aimed the James Webb Space Telescope, the very large telescope, and a fleet of other instruments at Atlas, they found more surprises. Exotic gases bubbled up, faint but unmistakable. Carbon monoxide, poisonous on Earth, but a potential building block in alien atmospheres. Cyanide compounds, the stuff of assassins on Earth, but also molecules tied to the earliest chemistry of life. Carbonyl sulfide, a gas linked to volcanic eruptions here, but in trace amounts thought to play a role in prebiotic chemistry, the chemistry before life begins. This is not the recipe of a local comet. This is a cocktail, a carefully mixed blend. Imagine opening a spaceship cargo hold and finding canisters labeled water, oxygen, carbon dioxide, cyanide. You'd know instantly you're not looking at random storage. You're looking at a stockpile. That's what Atlas feels like, a stockpile drifting through space. Now, let's slow down. Suppose this is natural. Suppose Atlas is just a freak of nature. What would it take? Maybe it formed near a star, rich in carbon chemistry, where water was scarce but CO2 plentiful. Maybe volcanic eruptions on some alien world blasted these gases into orbit, where they froze together into a comet nucleus. Maybe it wandered for billions of years until it found us. That's the safe answer. That's the science's usual explanation. But it's thin, because the chemistry doesn't just scream different, it screams designed. It's the ratios, the proportions, the precision. When you line up the elements, it doesn't look like chaos. It looks like intent. And here's a thought that'll make your skin crawl. What if the gases aren't random at all? What if they're a code? Think about it. We use ratios as signals all the time. Mathematicians talk about the golden ratio, the Fibonacci sequence, prime numbers. These are universal markers, patterns, any intelligent species would recognize. So what if the 8:1 CO2 ratio is itself a signal? A breadcrumb left in the chemistry saying, we know you're smart enough to see this. Decode it. Follow it. It's not just material, it's a message. Now take this further. What if Atlas is a life-seeder, a panspermia machine? Picture this, an automated probe designed to drift between stars, loaded with gases and molecules essential for life. It passes by young solar systems, heating up near stars, and boom, the chemicals release. Clouds of CO2, cyanide, carbonyl sulfide scatter into space, ready to rain down on planets. It wouldn't need to be fast. It wouldn't need to be flashy, it would just need to last. Over billions of years, one probe could seed countless worlds. One machine could play gardener for the galaxy. And when we look at Atlas's chemistry, it doesn't look like random gardening tools. It looks like a kit, the kit for building life. Now skeptics push back. They say we're letting imagination run wild. That chemistry can surprise us, that just because something looks designed doesn't mean it is, and they're right to be cautious. Science demands it. But ask yourself, how many anomalies do we need before caution becomes denial? First, the nickel. Pure, industrial grade, impossible without technology. Now the chemistry. Ratios flipped upside down. Gases that make no sense. Coincidence? Twice in a row? Or are we staring at the toolkit of a civilization far older than our own? Let's play with another angle. Suppose Atlas isn't a life-seeder. Suppose it's a terraformer. Terraforming is the dream of every spacefaring species. Take a hostile world, pump gases into its atmosphere, and slowly reshape it into something breathable, something green, something alive. On Earth, we dream of terraforming Mars. Pump CO2 into the air, melt the ice caps, trigger a greenhouse effect, warm the planet. It's crude, but it's the start of an idea. Now scale that up. Imagine a machine designed to drift into young star systems, drop CO2, release exotic gases, trigger chain reactions. It wouldn't need to land. It wouldn't need to build cities. It would just need to tweak atmospheres, nudge planets closer to habitability. And that's exactly what Atlas looks like. Not a comet, not a rock, but a terraformer on autopilot. But here's the twist. What if it's not building, but testing? What if the gases aren't there to create life, but to see how we react? Cyanide, carbonyl sulfide. These aren't friendly. In the wrong hands, they're poisons. In the right context, they're building blocks. So maybe this isn't a delivery. Maybe it's bait, like a fisherman dropping lures into the water, waiting to see which fish bite. If we notice the gases, if we analyze them, if we argue about them, then we've passed the test. We've proven we're advanced enough to decode the chemistry of visitors, and if we don't, then maybe the gardener moves on, searching for smarter fish. And here's the haunting part. We passed. We saw the nickel. We saw the gases. We decoded the ratios, and we're talking about it right now. Which means, if it's a test, someone, somewhere knows we noticed. So where does this leave us? With a visitor that breaks every rule we thought was unbreakable. Nickel without iron. Chemistry that looks engineered. Ratios that whisper intent. Exotic gases that point to life, or poison, or both. Atlas isn't just a rock, it's a riddle. And if Harvard's alarm was the opening bell, the chemistry is the second blow. Because now, the question isn't just what is it made of. The question is, why was it made this way? If it's natural, then our models of star systems are wrong. The galaxy is weirder, richer, stranger than we imagined. That alone would be enough to rewrite textbooks. But if it's not natural, if it's deliberate, then Atlas is more than a visitor. It's a courier, a gardener, a tester, a message, and one day, when we finally learn how to read that message, we may discover it was never about the metals or the gases, it was about us. Were we ready to see? Were we ready to listen? And most importantly, were we ready to answer? Space is vast, cold, empty. The chances of anything colliding or even brushing past each other are tiny. That's why when something enters our solar system from the great beyond, we expect one thing: randomness, a long arc, a graceful curve around the sun, a slingshot maybe before it's gone forever. That's the story every comet and asteroid has told for billions of years, but not Atlas, because the path of this thing, it doesn't look random, it looks planned. Let's start with the basics. Our solar system is like a giant spinning record. The planets all move in the same direction, more or less on the same flat plane. Think of cars driving smoothly around a racetrack. Sure, there are variations, some lanes wider, some narrower, but everyone's moving the same way. Now picture a car coming onto the track at 130,000 miles per hour, going the wrong way. That's Atlas, retrograde, against the flow. That alone is strange. Most interstellar visitors cut across the solar system at random angles because there's no reason for them to align with our planets. But Atlas didn't just align, it tilted only 5 degrees off the plane, practically flat with the planets, like it knew where the racetrack was. And then, instead of going with traffic, it turned and sped against it. Why? If you wanted to get the best look at every car on the track, you wouldn't merge and go with the flow. You'd drive against it, headlights on, seeing everyone as they passed. That's exactly what Atlas is doing. But it gets stranger. As astronomers tracked its orbit, they realized it wasn't just barreling through aimlessly, it was making a tour. First Venus, then Mars, then Jupiter. Each one close enough to study, close enough to feel deliberate. The odds of this happening by chance? 0.005%. That's less likely than winning the lottery 3 times in a row. Less likely than being struck by lightning on your birthday. Less likely than flipping a coin and having it land on its edge 10 times straight. At some point, improbable starts looking a lot like impossible. And yet, it happened. Let's paint the picture. Imagine a spacecraft entering a new star system. You want to study its planets. You want to map its layout. So you choose a path that threads them together, one after another, maximizing your view in a single pass. That's what Atlas is doing. From Venus to Mars to Jupiter, like ticking boxes on a survey checklist. It's not a rock, it's a tourist with a camera. And here's where things get really unsettling. When it reaches perihelion, its closest point to the sun, when comets normally shine brightest, it does so on the far side of the Sun from Earth. In other words, at the exact moment we'd want to observe it in detail, it slips behind the glare, hidden, obscured. Coincidence? Maybe. But if you wanted to design a probe that avoids scrutiny, that hides its secrets at the very moment of peak activity, this is exactly the orbit you'd choose. So let's recap. Retrograde orbit, tilted almost perfectly onto the planetary plane, a tour of Venus, Mars and Jupiter, with odds too small to call random. Perihelion, hidden on the far side of the Sun. Taken together, this isn't just weird, it's suspicious. It's the difference between someone bumping into you on the street and someone following you home. One is chance, the other is intent. Now, let's step into the mind of a designer. If you were building a probe to explore our solar system, how would you program its path? You'd want efficiency. One trip, maximum data. You'd want coverage. Multiple planets in a single sweep, and you'd want stealth. Avoid peak detection when possible. Check, check, and check. That's Atlas. And this isn't the first time we've seen something like it. Back in 2017, Oumuamua defied expectations too. Its trajectory was odd, its acceleration unexplained. Some thought it was natural. Loeb said maybe it wasn't. Now, less than a decade later, another interstellar visitor appears. And this one doesn't just accelerate strangely. It flies a path that looks scripted. One fluke is chance. Two flukes are a pattern. So what are we looking at here? Let's explore some possibilities. Scenario 1. Pure coincidence. Maybe the universe really did roll the dice this way. Maybe Atlas just happened to cut across our system at this angle, and we're reading too much into it. It's possible, but the math fights us. 0.005% isn't zero, but it's close. Betting on this being chance is like betting on the coin landing on its edge 10 times. Technically possible, practically insane. Scenario 2. Survey probe. If this is artificial, then its orbit makes perfect sense. It's a flyby mission, a cosmic tourist bus. Zoom in on Venus, check Mars, swing by Jupiter, take notes, and move on. In one sweep, you gather a panoramic view of the system. Scenario 3. Stealth mission. The perihelion trick suggests more than science. It suggests avoidance. Maybe this thing isn't here to announce itself. Maybe it's here to watch quietly without being caught in its most revealing moment. A spy in comet's clothing. Scenario 4. The test. What if it doesn't matter where it flies? What if the real purpose is to see if anyone notices? If anyone watches closely enough to see the pattern? If we spot it, we pass the test. If we miss it, maybe they write us off as not worth contacting. Each scenario is unsettling. Each one feels closer to design than chance. And there's another piece to this. Retrograde motion isn't just strange, it's useful. By moving against the planets, Atlas maximizes its encounters. It's like swimming upstream. You meet more fish that way. A probe moving retrograde can pass closer to more planets in less time, sampling atmospheres, measuring magnetic fields, snapping images. If you were writing the blueprint for an alien survey mission, you'd pick retrograde, and Atlas followed the blueprint. Think of it like this. You're standing on a street corner and a car drives by. That's normal, but then another car drives by, and another, all in the same lane, all at the same speed, normal traffic. Now imagine one car driving the wrong way. Not only the wrong way, but slowing down to look at every house, pausing at the stop signs, making deliberate turns. That's not traffic anymore. That's surveillance. Atlas isn't driving with traffic, it's the wrong way car. And every planet it passes is another house it peers into. So here's the haunting question. What happens after Jupiter? Does it just leave, drift back into interstellar space, never to be seen again? Or does it leave something behind? Some scientists worry that close flybys could be opportunities to drop things off. Probes, sensors, smaller machines. If you wanted to see the system quietly, you wouldn't need to stop. You just need to pass close enough to release. and Atlas is scheduled to pass near 3 planets in one trip. 3 opportunities. Coincidence or a plan unfolding before our eyes? The problem is, we won't know for sure. Its perihelion hides its secrets. Its retrograde orbit complicates tracking. Its speed makes close study difficult. All we can do is watch, speculate, and wonder. But wonder cuts both ways. Because if it's natural, then it's extraordinary. A freak of physics, a comet unlike any we've ever seen. That's amazing in its own right. But if it's not natural, if its path is deliberate, then we've just had a brush with alien strategy, alien intent, alien presence. And that's something humanity has never faced before. So here we are, an object on a path too precise to ignore. A retrograde tourist threading the planets like jewels on a string. A visitor that hides its closest approach from our eyes. It doesn't feel like chance. It feels like choreography. And if the universe is choreographing, then we have to ask, who's the dancer and who's the audience? The sun is a liar. It blinds us with brilliance, washes out the faint whispers of the cosmos, drowns delicate signals in oceans of fire. For astronomers, it is both a gift and a curse. The sun gives us life, but it also steals sight. And in October 2025, it will steal something more, because that's when 3I Atlas reaches perihelion, its closest point to the sun, the moment when comets typically flare brightest, their frozen interiors boiling away, releasing the secrets of their chemistry and structure. The moment we should see everything, and yet we won't, because Atlas has chosen a stage where we cannot look. It will flare on the far side of the sun, hidden in the light. At first glance, that might sound like bad luck, coincidence. The universe rolls the dice and we lose. But after everything else, the nickel, the chemistry, the orbit, this doesn't feel like chance anymore. It feels like strategy. Let's step back for a moment. When astronomers study comets, perihelion is the jackpot. That's when the heat of the sun cooks the ice, blasting out gases, dust, metals, jets of material that can be analyzed. It's when the coma brightens, tails stretch across millions of miles, and the object is at its most dramatic. It's also when we learn the most. We measure light at different wavelengths, revealing what the comet is made of. We capture jets to study outgassing. We track its orbit more precisely as solar heating nudges it. Perihelion is when comets show their true face, but not Atlas. When it unveils itself, Earth will be blind. The sun will be in the way, blazing at full strength, hiding the show behind its glare. It's like someone standing in front of a camera just as the truth comes out. Now, if Atlas is natural, this is unfortunate, maddening even. The best data, gone, blocked by circumstance. But if Atlas isn't natural, if it's a probe, a machine, a message, then this is not coincidence. This is cover. Because the best time to hide is when everyone is looking. Think about espionage on Earth. The best spies don't disappear in the shadows. They disappear in the crowd, in the noise, in the light. They hide in plain sight. Atlas, with its perihelion behind the sun, is doing exactly that. At the very moment of peak activity, it vanishes into the blaze. A magician's flourish, a sleight of hand. Don't look here. And here's where it gets eerie, because this isn't just inconvenient, it's suspiciously perfect. The orbit doesn't just hide its perihelion, it hides it exactly when the comet should be most active, when astronomers would get their clearest, richest look. It's like someone timed it, scripted it, and if you were designing a probe to disguise itself as a comet, wouldn't you choose exactly this trick? Let them see just enough to spark curiosity. Nickel, CO2, retrograde motion, but when they lean in for the reveal, step behind the curtain, show them mystery, not truth. So, let's ask the question, why hide? If Atlas is natural, the answer is obvious. It's not hiding at all. It's just bad luck for us. But if it's not natural, then the possibilities multiply. Possibility 1, concealment. The perihelion is when the comet's surface cracks, when jets erupt, when machinery, if it exists, might activate. Hiding that behind the sun keeps the trick safe. Possibility 2, deployment. What if perihelion isn't just activity, it's the trigger, the moment to release probes, smaller machines, seeds of technology? Do it behind the sun and Earth won't see. Possibility 3, signaling. The sun isn't just light, it's noise, a blinding source of radiation. If you wanted to beam a signal without us noticing, doing it while you're masked by the sun is genius. Who would ever see it in the static? In espionage terms, perihelion is the drop, and the sun is the cover. Now, imagine this from another perspective. You're building a probe to survey star systems. You know curious civilizations might exist, pointing telescopes skyward. You want them to see hints, nickel, strange chemistry, improbable paths, but you don't want them to see everything. So you design your orbit with intention, thread the planets for a tour, move retrograde to maximize encounters, but when it's time to flare, time to reveal the core, the engines, the truth, slip behind the sun, leave them guessing, leave them arguing, but never leave them certain, because certainty is commitment, mystery is control. And here's the part that gnaws at scientists. The timing isn't just bad, it's too bad. Statistically, the odds of such a perfect concealment lining up perihelion with Earth's blind spot are tiny. Combine that with everything else and it stops looking like chance. It looks like choreography. But let's play devil's advocate. What if it really is coincidence? Then nature is messing with us. It gave us an interstellar visitor that breaks every rule. Nickel without iron, alien chemistry, a suspicious orbit, and then, just when we might figure it out, it hides it behind the sun. That's either the cruelest cosmic joke ever told or the most brilliant piece of design. And here's where the paranoia creeps in. What if perihelion is when Atlas becomes most dangerous? We've talked about probes, surveys, messages. But what if this isn't passive at all? What if perihelion isn't concealment, it's activation? Behind the sun, where we can't see, what if something wakes up? What if machinery spins to life, powered by solar energy, hidden in the blinding glare? What if deployment isn't theory but reality? We wouldn't know. We couldn't know. And maybe that's the point. Think of history. The Trojan horse. A gift wheeled into the gates, beautiful, mysterious, and inside, something waiting. What if Atlas is the Trojan horse of the cosmos? Not here to destroy us, but here to test us. Here to see if we notice the pattern. Here to see if we panic or if we prepare. And the perihelion behind the sun, that's the closing of the gates. That's when the horse disappears from sight and we're left wondering what's inside. But let's not go all in on paranoia. Let's also consider awe. Because if Atlas is natural, then hiding behind the sun is just another reminder of how fragile our vantage point is. We're one planet, on one orbit, stuck with one perspective. The universe is full of secrets we'll never see because the geometry doesn't line up. And maybe that's the real message. Not that Atlas is hiding, but that the cosmos is bigger than us. But if it is hiding, then it's hiding on purpose. Now let's take this thought further. What if hiding is part of the signal? Think about human communication. We love puzzles. We love games. We love leaving messages with pieces missing, daring others to fill in the blanks. What if Atlas's perihelion isn't about concealment, but challenge? What if it's saying, you saw the nickel, you saw the chemistry, you saw the path, but now I'll show you what it means, only if you're clever enough to see around the sun. Maybe that's the test. Not just noticing the object, but finding a way to pierce the glare, to watch what we're not supposed to watch. And if we fail, then maybe we weren't ready. Either way, Atlas has played its trick. It's vanished into the light, and now we're left staring at the glare, blind, wondering what really happened when no one was looking. One anomaly is curiosity. Two anomalies are coincidence. But three is a pattern. And the universe is starting to look patterned, because Atlas isn't the first strange visitor from the stars. Not even close. In fact, it's the third in less than a decade. And when you line them up, the story that emerges is bigger and far more unsettling than anyone wants to admit. Let's rewind to 2017. A telescope in Hawaii detected a faint dot moving too fast, too oddly, to belong here. It wasn't bound to the sun. It wasn't looping like an asteroid, it was passing through. Astronomers named it Oumuamua, a Hawaiian word meaning scout or messenger from afar arriving first. And the name could not have been more fitting, because Oumuamua was unlike anything ever seen. First, its shape. It wasn't round like most asteroids. It wasn't fluffy like a comet. It was elongated, cigar-shaped, maybe 10 times longer than it was wide. Some said it looked like a shard. Others imagined a flattened pancake. Whatever it was, it didn't match anything we knew. Second, its behavior. As it passed the sun and began to move away, it accelerated. Not much, just a gentle push like an invisible hand nudging it faster. Comets do this when gas vents off their surface, acting like little rocket thrusters. But Oumuamua had no coma, no tail, no visible jets, nothing. It was moving too fast, in too strange a way to be explained. That's when Avi Loeb, the same Harvard scientist now sounding alarms about Atlas, made headlines. He suggested something radical. Oumuamua might not be natural. It might be a solar sail. Imagine a thin sheet of material designed to catch sunlight like wind in a sail. Starlight itself could push it across the galaxy. Most scientists scoffed. They called it wild speculation, but no one had a better answer. Oumuamua drifted out of range, unsolved, leaving only questions in its wake. 2 years later, in 2019, another visitor arrived. This one was named Two-Eye Borisov, after the amateur astronomer who spotted it. And unlike Oumuamua, Borisov looked more like a traditional comet. It had a coma, a tail, the usual cometary fireworks. But even Borisov was strange. Its chemical composition didn't match anything local. It carried more carbon monoxide than our comets, suggesting it formed in an environment far colder, far more alien than our own. For the first time, scientists had proof. Interstellar comets weren't just a fluke. They existed. They came. They passed through. But Borisov faded into the background. Unlike Oumuamua, it didn't shatter paradigms. It was weird, yes, but explainable. Scientists sighed with relief. Until now. Fast forward to 2025, Atlas enters the stage. And suddenly, the pattern sharpens. Because Atlas isn't just weird, it's the weirdest of all. Oumuamua bent the rules of motion. Borisov bent the rules of chemistry. But Atlas bends everything. Nickel without iron. Chemistry flipped upside down. A retrograde orbit threading planets. A perihelion hidden behind the sun. It's like the ghosts of Oumuamua and Borisov fused into one object, returning in a new form with new puzzles. And once again, Avi Loeb is pointing at the data and saying the word no one wants to hear: technology. So let's line them up. Ronwamray, a messenger from afar, accelerating mysteriously, shape unknown. 2019, Borisov, a comet but with alien chemistry, carrying too much carbon monoxide. 2025, Atlas, the third, the most bizarre bleeding nickel, flying a survey mission, hiding at perihelion. 3 visitors in less than 10 years. Coincidence or a breadcrumb trail? Here's the kicker. Space is enormous. The distances between stars are mind-boggling. If you waited for random rocks from interstellar space to wander into our solar system, you might expect one every few million years, maybe every 100,000. But 3 in less than a decade? That's lightning striking the same place 3 times. That's the dice coming up 6 over and over again. It suggests something we don't want to face. Either the galaxy is full of these objects, or someone is sending them. And that's where the pattern gets chilling. Oumuamua looked like a scout, a messenger. Borisov looked like a sample, a specimen from another chemistry set. And Atlas looks like a probe, a surveyor, scout, sample, surveyor, step by step, layer by layer, like stages in a plan. Are we watching a process unfold? Now imagine this as a sequence. First, a scout is sent, Oumuamua. Something light, fast, minimal. It sweeps through, checks the lay of the land, moves on. Next, a different kind of visitor. Borisov. Less strange, more like a comet, but still carrying alien chemistry. A test of reactions perhaps, a control sample, and then Atlas, the big one. The probe that doesn't just pass through, it tours. Venus, Mars, Jupiter. It hides when it needs to. It leaves a trail of nickel and gas like a puzzle begging to be solved. It feels less like coincidence and more like choreography. And here's a thought that gnaws at the mind. What if they're related? What if Oumuamua wasn't random? What if Borisov wasn't random? What if Atlas isn't random? What if they're all pieces of the same project? Different designs, different functions, different missions, but all part of a larger pattern, a network of interstellar probes, a galactic survey unfolding before our eyes, and we just happen to notice 3 of them in quick succession. But let's not stop there. Let's imagine what comes next. If this is a sequence, a pattern, a plan, what's step 4? If the scout has come, if the sample has passed, if the survey is happening now, then the next step could be something bigger. Contact, or colonization, or something we can't even name. What if Atlas isn't the climax? What if it's just the setup? Now skeptics will say we're connecting dots that don't belong together, that Oumuamua, Borisov, and Atlas are 3 separate stories, 3 random dice rolls. But even skeptics can't ignore the statistics. 1 interstellar visitor in 2017, another in 2019, another in 2025, 3 in less than 10 years. After billions of years of silence, it feels less like dice and more like a signal. And let's not forget the names. Oumuamua means messenger. Borisov was just a name, but it carried alien chemistry. Atlas, named after the telescope, yes, but think about what Atlas meant in myth. The titan who held up the heavens, the figure who bore the weight of the sky. Messenger, alien chemistry, bearer of the sky. Even the names sound like chapters in a myth, a cosmic story unfolding across decades. So what's the pattern telling us? Maybe it's this: we're not alone. And maybe the universe has been trying to tell us that, not once, not twice, but 3 times. The problem is, we've been too busy arguing, too busy dismissing, too busy clinging to natural explanations to see the bigger picture. Oumuamua, Borisov, Atlas, 3 dots, 1 line, pointing straight at a truth we can't ignore forever. And here's the scariest part. If this is a pattern, then we're not just observers, we're participants. Because every time one of these visitors appears, we react. We scramble telescopes, we write papers, we argue. And maybe that's the test. Maybe the pattern isn't about them. Maybe it's about us, how we respond, what we notice, whether we're ready. And if we are ready, if we've proven ourselves, then maybe the next visitor won't just be a comet or a probe or a messenger. Maybe the next visitor will be something far harder to ignore. So where does that leave us? Standing under a sky that's no longer silent, watching as 1 anomaly becomes 2, then 3, realizing that coincidence doesn't stretch this far, and asking ourselves, is this a pattern of nature or a pattern of intelligence? If it's nature, then the galaxy is stranger, richer, more alive with interstellar wanderers than we ever dreamed. But if it's intelligence, then the pattern is a plan, and the plan is unfolding right now above our heads. When faced with the unknown, the human mind does what it always does. It builds stories. We look at the evidence, we connect the dots, and we ask the question that drives every mystery. What is it? With 3i Atlas, the question is louder than ever, because the evidence doesn't fit the box of comet, asteroid, or random rock. It leaks metals, carries alien chemistry, flies deliberate paths, hides at perihelion. So if it isn't just a comet, then what is it? Let's explore the theories. Theory 1. The alien probe. This is the one that thrills some and terrifies others. The simplest explanation, if you take the evidence at face value, is that Atlas is artificial, a machine, a probe from another civilization. Think about how it behaves. It surveys planets, It hides when scrutiny peaks. It leaves behind chemical breadcrumbs. Its orbit maximizes data collection. That's not a rock, that's a mission profile. If it's a probe, then the purpose becomes the next question. Is it a surveyor? A scout designed to map solar systems, catalog planets, measure atmospheres, and move on? Is it a message? A delivery system carrying a signal encoded in metals and gases, meant to be noticed by civilizations advanced enough to decode it? Or is it a test? A probe designed not to explore, but to see who's watching? Each answer is unsettling. Each answer changes our place in the universe forever. Theory 2. Cosmic garbage. Not every artifact is glorious. Some are trash. Maybe Atlas isn't a probe with a mission. Maybe it's a fuel tank, a discarded engine, a chunk of debris left over from a civilization's bigger project. The nickel trail, industrial waste. The gases, leftovers from an alien factory. The orbit, pure accident. Think about our own space junk. Earth's orbit is littered with dead satellites, broken rocket stages, fragments of machinery. To an alien astronomer, they might look puzzling, metal where there shouldn't be metal, paths that don't quite match natural objects. What if Atlas is the same, but on a galactic scale? An alien civilization dumps its waste, and after millions of years, the garbage drifts across the stars until it lands in our backyard. It's not glamorous, but it's possible, and if true, it carries its own eerie weight. Because if their garbage is this advanced, what does their technology look like when it's alive? Theory 3. The von Neumann probe. This one sounds like science fiction, but it's science fact in concept. John von Neumann, the mathematician, once proposed the idea of self-replicating machines. Build one probe, give it the ability to mine resources, replicate itself, and launch copies. In theory, such probes could spread through an entire galaxy in a few million years, an eye blink in cosmic time. If Atlas is a von Neumann probe, then the nickel isn't waste, it's a raw material. The gases aren't leftovers, they're feedstock. It could be in the process of replication, using solar heat at perihelion to kickstart processes, gathering data, searching for suitable raw material. If this is true, then Atlas isn't just a probe, it's one of many, and the galaxy could already be full of them. And here's the chilling thought, we might not be the first to notice. Other civilizations may have seen their own Atlas, their own probes passing through. Maybe that's the hidden truth of the Fermi paradox. The galaxy isn't silent, it's just seeded with machines. Theory 4. The seeder or terraformer. Now let's flip the story. Instead of being a scout or a spy, what if Atlas is a gardener? Its chemistry screams this possibility. The overwhelming carbon dioxide, the exotic gases like cyanide and carbonyl sulfide. These aren't random, they're ingredients. If you wanted to seed life across the galaxy, you'd design a machine to carry essential chemicals, drift it into young star systems, let it pass near suns to release its payload, shower planets with the raw materials of life. That's panspermia on autopilot. That's galactic gardening. Atlas could be a terraforming probe, sprinkling gases into atmospheres, tweaking conditions, preparing worlds for colonization or for life itself to take root. If that's true, then maybe Earth is already the product of such machines. Maybe billions of years ago, another Atlas passed by, seeding the gases that eventually sparked us. What if we're not just observers of Atlas? What if we're its descendants? Theory 5. The natural forge. Of course, not every scientist wants to leap to aliens. Natural explanations are still on the table. Wild, exotic, but natural. Some suggest Atlas could be debris from a kilonova, a collision between neutron stars. These titanic events forge heavy elements, blasting out metals like nickel across galaxies. Others propose an asymmetric supernova, where a lopsided explosion might separate nickel from iron, sending chunks of one without the other into the void. Maybe Atlas is a fragment of one of these ancient cataclysms, a relic of stellar death, frozen for billions of years, only now crossing our path. It's possible it fits some of the data, but here's the problem. Even if a kilonova made Atlas, how did it end up on a path so precise, threading our planets, hiding its perihelion? The chemistry might be explained, the metals might be explained, but the orbit, the choreography, that's harder. Theory 6, the cosmic test. This one is more philosophical than scientific. What if Atlas exists simply to be noticed? Not as a probe, not as a cedar, not as garbage, but as a test. The anomalies are the exam questions. But do you see the nickel? Do you notice the chemistry? Do you calculate the improbability of the orbit? And our reaction is the answer. If we don't notice, we fail. If we notice but ignore, we fail. If we notice and argue, maybe we pass. If we notice and understand, maybe we graduate. This theory suggests Atlas isn't a comet or a probe or a machine. It's a message in a bottle, a lure tossed into the galaxy to see who's paying attention. And if that's true, then someone, somewhere, is watching. So which theory is right? The truth is, we don't know, and maybe we never will. Atlas is moving fast. It'll pass perihelion, swing by Jupiter, and vanish into the dark. By the time we marshal our instruments, the moment may be gone. But here's what matters. None of the theories are comfortable. If it's a probe, we're not alone. If it's garbage, someone out there is so advanced their trash looks like magic. If it's self-replicating, then the galaxy may already be theirs. If it's seeding life, then we may owe our existence to machines. If it's natural, then the universe is far stranger and more violent than we imagined. If it's a test, then we just raised our hand and said, yes, we're here. Every explanation carries weight. Every explanation changes how we see ourselves. And maybe that's the real story. Atlas isn't just a comet, it's a mirror held up to humanity, forcing us to confront possibilities we'd rather avoid. Are we alone? Are we watched? Are we children of machines? Are we ants in a galaxy of giants? Theories swirl, debates rage, but the truth drifts silently above our heads, trailing nickel and gas, following a path too perfect to be chance. Whatever Atlas is, one fact remains: it's not ordinary, it's not forgettable, and it's not just another rock. It's a story, a question, a challenge, and the answer may define the future of humanity.